Yeah, yeah. Okay, so Signed, Sealed, Delivered Zone by Stevie Wonder, and I've got a little soft spot in my heart for Stevie Wonder, so I might dance, I might not. You'll find out. It's fine. So what I want to start with is this factored word. We have done this before. So factoring is the inverse of distributing. So if I have 3x plus 2, distribute-wise, that leaves me with 3x plus 6. Well, to factor it, it is the absolute opposite. What number can be divided out? Well, we can divide 3 out of both, so that really leaves me with 3, because that's what got divided out, that's what got factored out, multiplied by x plus 2, okay? Factoring is the inverse of division, and that's key, because that's what we're going to be doing. Where'd my keypad go? Somebody stole it. I don't like that. Okay, solve each equation. I'm not going to make you solve these. It's 10. It's negative 40. I want demanding Dwight. That's something. Demanding Dwight insists that you give him 2 solutions to the following equation. Can you provide him with 2 solutions? Well, this is not something that we've normally seen. This is saying x minus 10 equals 0, or x divided by 2 plus 20 equals 0. When you have multiple quantities getting multiplied together that equal something, in this case a 0, and they will always equal 0, we're going to think of them as separate equations. And I would really rewrite them as x minus 10 equals 0 and x divided by 2 plus 20 equals 0. Well, we already know that this one's going to equal x equals 10. We already know this one's going to equal x equals negative 40. And if you're like, Mr. H, how do I know that? Well, because those were the 2 examples that we just skipped. So how would I write this? Well, it's an or statement. So demanding Dwight's going to either get negative 40 or positive 10. So now here's the next portion, and this is important. Demanding Dwight wants 5 solutions to the following equation. How many different sets of parentheses do we have? 1, 2, 3, 4, 5. So is it possible to have 5 separate equations, or 5 separate solutions? Yes. So x minus 10, we know x is going to equal 10. There's 1. 2x minus 6. So if I subtract 6, that leaves me 2x equals negative 6. I'm going to write this one out. So the goal here is to have all of these equal 0. So this equals 0. Subtract 6. 2x equals negative 6. Divide by 2, x equals negative 3. So now I have another solution, x equals negative 3. Let's take this one. X squared minus 36 equals 0. Can I see that? Yes, I can. Well, I need x squared by itself, so I add 36. Here's where it gets a little bit confusing. X equals 36 would be easy, but it's x squared. So to find the x value, I have to take the square root of both sides. As soon as I take the square root of both sides, I know that I have 2 answers, both a positive and negative, and it will be 6. So now I have x equals positive 6, and x equals negative 6. I'm only 3 through this, and I've already got 4 answers. Oh man, let's see what happens. X squared plus 10 equals 0. Well, I subtract 10 from both sides. X squared equals negative 10. Take the square root of both sides. Is there anything that I can take the square root of that's going to be negative? Well, no. So this has no solution. So x has nothing. It is no solution here. So this one is garbage. This one is garbage. That only leaves me with this last one, which we've already solved, which means x equals negative 40. So how would I write these? Well, I'd write them as negative 40, negative 6, negative 3, 6, 10. Those are my solutions. Do you think there might be a 6th solution? Well, not for this one. There could be in some others, but absolutely not in this one, because we've checked each and every one of these equations. The way that I would say this is x could equal 10, or x could equal 6, or x could equal negative 3, or x could equal negative 6, or x could equal negative 40. When we're solving multiple solutions like this, it's an or statement. Will it always be? Yeah, for what we're doing. So the goal with this is really to break it apart into multiple equations. And if you're still confused, in between these parentheses, this by itself is going to be an equation. That by itself is going to be an equation. This, and this, but each of these have to equal whatever's on that right side. So each equation for this one is going to equal 0. So there's 5 separate equations that we're going to have to solve for. Mr. H, you've lost me, you've confused me, you're a jerk. Yeah, all of those are probably true. So let's keep going. Let's see what else we got. Okay. Consider the equation x minus 4 multiplied by the quantity of x plus 3 equals 0. Well, it says rewrite the equation as a compound statement. What we need to understand is this is really saying x minus 4 equals 0 or x plus 3 equals 0. Well, does that make it a little bit easier? Yeah, you know that this x equals 4. You know here x equals negative 3. Both of those are solutions. So what's going to be my solution set? Negative 3 or 4. That's how we are going to write this. Now, why does this become tricky? Because Mr. H, that doesn't look tricky. You're absolutely correct. That doesn't look tricky. But sometimes you're going to get equations like this, where you're going to look at it and say, well, if I add 10x to the other side, how do I get the x's by themselves? Correct. This is where factoring comes in. So the first thing that I look at when I have an equation like this, so I have 2x squared minus 10x equals 0. What can I factor out number-wise out of both terms? Well, I look at the smallest number and it's 2. Can 2 go into both of my terms? Yes. So I can divide both by 2. But we're not done there. Is there a variable that's exactly the same in both? Yes. What's the smallest variable it is? Well, this is x squared. This is x. The x can come out of both. So now, when I rewrite this, I have 2x multiplied. Well, 2x squared divided by 2x, and this is where I'd go back and watch the pre-algebra videos, Module 1, Lessons 1 through 5, to learn about exponent rules. Module 1 in pre-algebra, Lessons 1 through 5. X squared divided by x, we subtract the exponents. 2 minus 1 is just x. Minus 10 divided by 2 is 5. X minus x is 0. So that leaves me x minus 5. Well, what does this still have to equal? 0. So Mr. H, how are you going to solve this? The same exact way. It's 2 separate equations. So I'm going to bring this equation over. This is 2x equals 0, and this is x minus 5 equals 0. So solve it. X equals 5, divide by 2, x equals 0. So now what do I do? Well, I put it in my set notation, 0, 5. Because this is an or statement. Both of those could work. Okay? Example, excuse me. Example 2 is trickier. And I'm going to come up, get close because I need to see the time. So it's 8:32. That will change as soon as I finish this. So this is trickier because you have to distribute first. X squared, so this is x squared minus 3x plus 5x minus 15 equals 0. So now I have x squared plus 2x minus 15 equals 0. Well, I can't factor anything, so what should I do? Add 15 to both sides. Always combine your constants if you can. So now I have x squared plus 2x equals 15. So now I'm just going to bring this up so I have more room. X squared plus 2x equals 15. Is there something that I can factor out now? Well, yeah, there's no number that I can factor, but there is a variable. So I divide both by x. So x comes out, that leaves me x plus 2 equals 15. Well, Mr. H, how do you solve this? Separate it. X equals, well, what's on the right side? 15. There's one of my answers. That is the answer. X could equal 15, or you have to solve x plus 2 equals 15, subtract 2, x equals 13. Well, how do I write them? 13 or 15. Plain and simple. Let's do a couple more examples. Let's see if it stops. Okay. So when I say, hey, let's see if it stops, I know it doesn't stop on yours, but it stops on mine. I only have 10 minutes on WeVideo on my phone. So after 10 minutes, I have to start it all over again, which is why sometimes I'm like, I have no idea where I'm at, because I'm in the throes of teaching, and then all of a sudden it does that. So what I'd like you to do is get a solution set for these. So pause me, do those three. Go. Do those three now. Go, go, go. Go, go, go. Go, 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 go. Pretty easy. Come on back. This is going to be -2, -1. -2, -1. This one I add 2, I divide by 3. So, or subtract 12, so it's going to be -12. And that's going to be +2/3. This one, they're the same. So if I add 3, I get 3. That's it. Plain and simple. We're only going to have one. Okay? So if there's two things, you're either going to have 2 answers or 1 answer for the most part. Okay? We're going to spend some more time with this. If you have questions on those, that's something that I would mark down and say, Mr. H, I'm having trouble. Can you help me? So here, just looking, I should have 3. I should have 3. But we don't know how many we're going to have here yet. Oh, actually, let's look at this. I don't know if I'm going to have 3 because I've got to simplify. So here we're going to have to factor. Here we have to simplify and then factor. Okay, so sometimes these take a little bit more work. I'll do one more with you because I'm nice like that. Let's do this last one. I distribute. X squared minus 5x plus 4x minus 20 equals 0. Combine like terms. X squared minus x minus 20 equals 0. I add 20 because I want to get rid of those constants from the side before I factor. X squared minus x equals 20. Now can I factor this? Absolutely. Divide out x. That leaves me, I'm just going to bring it up over here. X times x minus 1 equals 20. Where'd you get the 1 from? X divided by x is my 1. So this is my line. X equals 20, nice and easy. X minus 1 equals 20, add 1. X equals 21. So when I draw it, 20, 21. Bam. Compound statements. Love them. Factoring. Love them. Questions, concerns, problems, you're going to have to ask me the next day. Good job.